Welcome. Unity 3D tech session. So everyone knows what Unity is, yes? Cool. So why Unity? Because why not? Something I've been playing with for a little while now, a few weeks. As I spoke in the summit around high bandwidth user experiences and extended reality stuff. So I thought it would be cool to play with some Unity, or like something in the 3D space. And so like Unity seemed pretty easy, and it's like properly easy. Like, this is not like you don't need to you don't need to relearn any new language. This is like a new little tool that you can make shit in 3D. It's unbelievably cool, actually. I think it's easier. I'm not an expert in Unity, but I feel like I could probably figure out almost anything in maybe a week. Compared to like React, which probably took me a month to go like, I think I might know how this works. Like I have a vague idea of how React works, right? So like Unity and stuff are like much simpler than any web framework you've ever had to learn, in my opinion. Okay, so I'm not going to give you any theory on Unity. Like let's just bullshit, and then I think you'll just figure it out. So people often say, well, why are you looking at Unity and not Unreal? Or like there's this other thing called Godot. They've got different licensing. So Unity is not, it's like free, but it's not really free. I think if you make more than $100,000 a year, or your company makes more than $100,000 a year, you need to move to a Unity professional license, which I don't know how it works. I don't know. I think it's $3,000 per person or something like that per year. If you're using Unity for free stuff or for where you're not making more than $100,000, then it is free, sure. Unreal is also another game engine, and its commercials are they just want 5% of everything. That is their thing. So if you sell your game, I think once you've sold more than $1,000, then they just want 5% of everything. So even if Synthesis chose to use Unreal, we'd have to give up 5% of our turnover, of like our revenue. Not just of that little thing, it's like of your company's revenue. So Unreal's got a very clever TNC, yeah.
We'll start a new company called Synthesis Games, which
you'd have to do
bit
that.
of revenue.
Yeah,
Okay,
which sells free games, or something. So, but Unreal and Unity are both very popular. There's pros and cons against each of them, etc. Then there's another engine called Godot, which looks actually really cool. It's proper open source, no licensing, nothing. But of course, because it's probably a little bit behind, a bit more tricky to use probably. Unity and Unreal focus big time on the game development experience. They've made it like really easy. You really don't have to be a maths PhD anymore to understand matrices and quaternions and all this stuff. It's literally draggy, drop it. Like a moron like me gets it right very easily. But I reckon if you figure out Unity, I think those things translate very quickly to Unreal and Godot. They both, all three of them are very object-oriented. So everything you build is object-oriented. So it's like, which is weird for me, but it maps really well to games. It's because you're generally building physical shit, right? It's like a table and a person, and then they shoot each other and they have health, and like it makes sense, an OO type of view. However, as I started playing with all of these things, there's this other thing called Blender, which is probably very important to learn. So if you're going to build anything meaningful, you'll see in Unity it's very easy to like throw blocks around. We can make games where you shoot blocks, brilliant, or you make things that jump over blocks, and like blocks are fine, but like at some point you're going to go, like maybe I need a house, or I need to build this table, and then you basically buggered. In all three of those games engines, they're really not good 3D modeling tools. Whereas Blender is, and it is very difficult. Blender is not simple. And so even with Blender, I've spent like 2 weeks, and I think it's like, oof, I really don't know what I'm doing. But I've managed to figure out a way of getting a model into Unity, and then I go, okay, cool, that's all I need, nothing more than that. So that's probably worth. So I thought for today, like what would be a cool game to build while I was staring at that dinosaur, and then I went, oh yes, we could build the dinosaur game, right? So here was my concept art. Because you have to start with concept art when you're developing games. You can't just write code. You need to communicate. You have to get VC funding, all that stuff. So I've done that. That was my concept. We're going to build a cool dino thing. So there's like a 3D, so it's 3D, on a plane maybe, and then you have a dinosaur, and he can jump, and then maybe trees come at you. And they like appear somewhere, and they go faster and faster, and then you have to jump over them. Maybe have a score. Probably if you hit a tree, you die. I never got to the bird thing, so that's like this is MVP 1. And that is it. Okay, oh yeah, so here's the list of things we should probably do. We're going to build a cool dinosaur. We're going to build a tree to jump over. We're going to make that dino jump. Probably making him jump implies there's the ground or something that he must land back on. We're going to generate and move some trees. Stretch goal, we're going to keep score. And then profit from the App Store. So like, very simple. And from this, of course, you can build Flappy Bird, Flappy Dino, whatever. Okay, so let's go. Here is Unity. I've already created a little project. Like this is literally file new. I just have kept some cheating things in a folder there, which we will not be referring to, which I may refer to because some of it's a bit weird. Okay, so what are we going to do? What was my list? We're going to build a dino. Okay, cool. So this is how you start in Unity. You literally have, so just a quick overview. I've like set my workspace up in a certain way. This is not the default way, but this works for me. You've got a scene view, you can like build shit in here. So everything around in Unity is has these kind of 3 objects. You've got things called assets, which live in this project view. These are really just like files on disk. I'm looking at the files, right? Then I have the concept of game objects. Game objects are things which exist within a scene. So now I've talked about a scene. So a scene itself is also a game object. So assets, game objects, and then game objects are made up of components. That's it. There's nothing more, those 3 things. So we build assets. When I drop assets into a scene, they become a game object. And when I click on those game objects, I will see their components here. So in fact, there's already 2 game objects in my scene. This is my scene. It's called Tech Session. I could create more scenes if I wanted to. So you get many different scenes. It's fine. Like it could be level 1 and level 2. Those are 2 different scenes. Or I have a main menu. That's a scene. And then the game level 1 is a scene or whatever. So scenes are like these things which probably have got cameras and lights and render and shit. But you can put all different assets in like shared reusable assets inside a scene. So another cool use case for a scene is like I'm busy building that dino and I want to teach it to jump or whatever. And I don't want to do that in the game yet. I want to do it kind of in isolation. Like I want to build a little test case around, that could be a test scene, with just my dinosaur in it. I'm building that. At some point I'm happy with the dinosaur, he's able to jump, then I can drag him into like the main scene, right, and use him there. So like scenes are just different collections of game objects together. But I'm in the Tech Session scene. So there's already 2 things. There's a camera if I click it, and I like zoom out on my scene view. I can see that there's a camera in the world. There he is. It probably looks out at something. There's a little cool preview. When you click on camera, you get it there. But then the components of that camera are here on the side. So a camera's got a transform, it's got a camera, and it's got an audio listener. There's also a light. If I click on the light, there it is. There's a light. I can double click it. I shouldn't look at that screen, it's very slow. And I can like rotate myself around that light, like awesome, there it is. It seems to be, I don't know, blasting some light in a direction. Lights have got different components. It's got a transform still, but it also has a light on it. Makes sense. Okay, we don't really care about that stuff. We're going to start with the dinosaur. So how are we going to build our dinosaur? We probably want to start, I just right click. I'm going to build this not as an asset yet. I'm building it directly as game object. So I'm going to create like, let's see, my cool dinosaur. I use these capsules. This worked quite well. Like put a capsule, like that kind of looks like a dinosaur's body, sure. So that's its body, no problem. So let's in fact call this the body. And I'm using another keyboard because my Mac keyboard is now broken. No other reason. So one interesting thing is like when I created this object, it sort of put it in a strange location in the world. So if I'm looking at my world, somewhere in this world is the center, like 0, 0, 0. When I created it, kind of stuck it in a weird location. So this is its transform. A transform is common to every single game object. Every single one in Unity has a transform. A transform tells you what position is it, in what rotation is it, and what is its scale. So how big is it, how's it rotated, where is it looking, and what's its position. So typically when you're building stuff, you kind of want everything in the center. So you just right-click on component and say reset, and then it like sort of disappears off to the middle of the world. If I click on it now, it is positioned in the center of the world, and there he is. The other cool thing is I can look at this XYZ coordinates, and I can kind of get some idea of how stuff is facing. So I can see the x-axis is that red arrow there. I can see the Z is the blue, and Y is up. So you kind of got this thing where it's like, if it's X, Y, Z, your like coordinate system looks like that a little bit. So you've kind of got X and Z are your flat plane, and you've got Y going up and down, right? The other cool thing is you can click on these things and go to that perspective. So if I click on Y, I'm seeing stuff from the top. X, I'm seeing it directly from the X, Z, etc. And I can kind of see that there's a very faint, you can see the plane sort of in the background. I don't know if you can see that. And you can kind of see that it's centered very much in the center. We can see it there, of course, as well. Anyway, there's the body. Let's go and create a head. I think we're going to use another capsule, why not? He ends up jumping in almost the same place, except like a head should probably be a little bit higher. And it's like, check, this is where you can now see that stuff like Blender could be useful. We probably want to rotate this thing. I can't see my handles, there we go. Like, let's make a head that like looks down a little bit, and then we want to like push it forward a bit, move it up. So it's like cool. Like that looks like a dino's head. Hey, totally right. So we're happy with that. We can see the rotation stuff is there. Now we want to just make it. Are we happy with this dino yet? We want more dino, no more. Okay, so let's make it some legs. I'm also going to use capsule. I'm going to call this like the right leg. So right leg, the way he's facing would be on this side, right? Okay, cool. So we're going to pull it down like there a bit. Probably if we look at it from the front, that might be okay. From the back, it's kind of there. It's probably too big. So let's scale it down like 0.5, 0.5, 0.5. Sorry, there's a 0.51 there. Probably too small, whatever. You guys are going to make much better stuff. If we look from the top, it looks like it's kind of in the right place. From the front, looks okay. Okay, so we're happy with the right leg. Then we can duplicate that thing. Control D. Oh, I'm on a Mac. Command D, sorry. And then we can make this the left leg. So we could say actually on the right leg, we could see it was minus 0.7. Let's make it 0.7. This guy we're going to make 0.7, and then they'll be kind of evenly-ish spaced away from each other. Yeah, they look good, right? Cool. Dinosaur done, right? There is Dino. This is now his left leg. This is just because you must, of course, name your stuff. Very important. It's not important at all. It's just OCD. So that's pretty awesome. We probably want to give this Dino like a look. So at the moment, he's just game objects. They don't exist as assets yet. Anyway, there's our scene. So if we're building our project in this text session directory. Probably what we want to do is create like a material for this thing. We want him to be green, right? So what I would do is like create a material directory. And now as an asset, we're going to create a material. We're going to call this Dino body or whatever. A material can have a color, which is awesome. So I think dinosaurs are generally green. I don't know. Are they? Brown. I don't know. I couldn't find brown. Is that brown? That's orange. Green, right? Yeah. Okay, green. Blue? No. So there's our material, and then we can literally just drag it like onto stuff. So we can say, drag that material, and it's like, you can kind of see the green is kind of showing up, but it's probably our light. You can see it's like it's definitely affected by light. So we could probably take our directional light and maybe like make it more intense, and we could see a bit better. Other issue is like, okay, it's very much a directional light, right? So we're seeing shadows cast on everything. So maybe what we should do is take that light. This is my little cheat. The directional light doesn't actually matter where they're placed. They're purely an angle type thing. Just kind of duplicate him, put another light in the scene, and like rotate him a bit to just sort of like cast a bit more of a different shadow, like maybe like that. And then we can like doesn't matter actually where he sits. But now probably our dino, if we go back to him, is like a little bit better lit. Anyway, you can fuck around with that stuff for hours. We're not going to do that. Okay, cool. So now, but actually we haven't created a dino if you look at this thing. We've just created a bunch of objects. So we probably want to group them up, right? So the best way to do that is you create an empty. So an empty is just a game object that really has no components other than a transform. So it's just a thing that is in the world. It really has nothing. So probably this is actually the dino. And if we take these components, we can kind of child them under there. We can say actually the dino is a empty. It's just got a transform on him. But as children, he has these other 4 transforms. Plus with meshes being rendered in them, right? So what you can already see here now is there's a parent-child transformation happening. So if I just took this body and I rotated it like this way, I would be able to rotate the body. And it's like, well, that's cool, but like, you don't just rotate. If I want to rotate the dinosaur, I don't want to rotate them all independently. I just want to rotate the dinosaur, right? So if I do that now, like the whole thing transforms. Like those children inherit their transformation from their parent, right? So if I scale, for example, if I make it double the size, now the whole dino scales equally, right? Does that kind of make sense? So you got this parent-child things, transformations flow down. So children transforms are affected by their parents and their parents and their parents up above them. So that's really that relationship there. So we can now take the dino and we say, like, we messed with it, and we can just reset him back to the center of the world, and that's cool. All the children reset. So very cool. However, I've just got one dino, so just to close the loop, I want to turn this probably back into an asset. My dinosaur is not just a collection of game objects, probably an asset. I want to reuse it somewhere else. It's literally, I just drag it back onto my assets, bonk, and now suddenly I have this asset called dinosaur. You've also seen my game objects now have turned blue. So this means effectively I've gone from just having instances of these things, I've gone and created like a class. It's a thing in Unity, it's called a prefab. So I've prefabbed this thing, meaning that I can now use it many times. So I could then drag the dino back in, and I could have many dinos now as instances. Does that kind of make sense? I can put dinos down, I can rotate them all independently, they can all be different. They're all different instances of the same dino. But if I went and then edited that prefab again, so say, I don't know what I did, maybe I create, so let's create a new material maybe, another one, call it another, and maybe we want to go a bit orangey or something. Purple. It's dinosaurs, man, dinosaurs. So I can take this another thing and I can apply this to like instances, right? So I can do this. So it's like, cool, I changed those 2 okies. And it's like, okay, that's a bit weird because these are all meant to be the same type of thing. Unity is very clever though. This is really actually what Unity manages, is the fact that I have this idea of prefabs, instances of those prefabs, and then the ability to customize them. But it will also track those changes. So like if I go and say, for that dino where I changed it, I can see up here he is, dino 1, and I can see that he's in a different position. I can click this overrides and it says, oh yeah, this overrides the dino in your scene. And what he's changed is the mesh renderer. And if I click on that, you can see the element is different. I'm using another material versus that dino. So I could choose to say at this point, I could say, oh no, I didn't want that, so I could revert it. Or I could say, actually, no, apply that change back to the prefab. So I could do that, apply that, and now suddenly all my dinos receive that change. Do you know what I mean? So it's really just the ability to manage. So that's what a prefab is, like a pre-made thing. I can drop them into my scene and I can change them and customize them. But then if I do, I can choose to pass those changes back to the prefab, which will then update all the instances, or I can choose to revert them, right? And it's just through this very simple little. So now I can see for that dino, there's no overrides against the prefab. The fact that it's a blue thingy here shows me that it's an instance of that prefab. That's kind of, like, you can go into much more depth, but that's good enough, I think. Good enough to know that prefab thing. So I'm going to delete these guys somehow. There we go. So I'm cool with that dino, right? We got a dino. Perfect. What else do we have to do? We have to create a tree. Okay, so we know how to create a tree. We're going. So probably we know how trees work now. We want to probably create an empty, and we say this is the tree. We want to reset that to the middle of the world. I could now say, you know what, I want to build this thing as a prefab from the start. I don't want to build it as a bunch of objects and create a prefab later. So I can just drag tree back to text session. It becomes a prefab. It's already a prefab there. I can edit the prefab directly here. If I double click it, I go into now like this weird other mode where I'm editing only the prefab. And here's the magical back button up there to go back to the scene. I could also go to the tree here and I can click that little forward arrow there, which is go and open that prefab. I can also go back here, I could click there, and I could also say open there. There's 3 different ways to get to the prefab thingy. And now I can just build my tree. I don't know what do trees look like. I think they look like boxes. I'm going to reset that to the middle. I'm almost happy with this tree. Probably just the color, tree.
We need 2 boxes.
Do we want 2? I'm going to make my trees red. Yeah? We're going to put the tree there. Bonk. There we go. Done. Tree done.
Smaller green.
Okay, so now we've got a tree. He's at the same place as our dino. It's probably a bit weird. We'll put him there. It kind of looks okay. I'm happy with it. I don't need him in my scene, actually, because probably later we're going to generate some trees. But the cool thing is I can delete him out of my scene. I've still got him as an asset down there, right? So probably what I should have done is go and create folder prefabs. And go on, actually, dinos are prefab and trees are prefab. So I've got two prefabs, a scene, and 3 materials. So people who like to make structure, this is a happy place. And you can move things around, doesn't matter. Unity figures out all the stuff. I've never confused it. Okay, once or twice. Okay, so what we probably should be doing is like this dino needs to be able to jump on stuff, right? Actually, let's put a tree, why not? So let's make a little world for him, right? Because this is a cool world, but it's just sky. So one of the cool things, actually, let's do this now. We're gonna use physics, right? So the jumping action of this dino is going to like propel him into the air, and physics is going to make him come back to Earth, right? So we can apply physics is really easy in Unity. The built-in physics stuff is really easy. I'm just going to go and do this directly on my dino. So to do this, we just add a thing called a rigid body. So a rigid body means it's a thing that takes part in physics, rigid body. So they have a particular mass, so you could model this properly and say, actually, a dino is like a 2,000 kilos. We could say, yeah, it's 2,000 kilos. So this mass actually is like mass unit. So as long as you have the same unit, it's like good. This could be, I don't know what this is going to do. I'm going to leave it as 1. There's a particular drag, angular drag, use gravity, absolutely, cool. So, oh yeah, what we never do is we never press play on our scene. So actually, let's take this rigid body off, remove it. We can just press play, and this will now render the game. There's our game. It's working beautifully. We've now also flipped into like a game tab here. So this is showing us the game view. We can, while we're playing, so while that little button is pressed, we can go back to the scene view, and we can actually see stuff. So we're kind of in a debug view, so I could move the dino around or whatever, and if I go back to the game view, I'll see the dino's moved. And so like I'm interactively messing with the thing while it runs, right? Which is pretty cool, actually. When I press stop, any changes I've made will be reverted. So those will all like debug type of, like debugger changes. So one mistake I've made often is like make a whole bunch of changes while the thing's running, and then you press stop and it's like, oh, do it all again. So don't do that. So you can run them independently, no problem. Okay, so we saw, it was via our main camera. So there's our camera. You can see it's kind of looking down that way. Probably the view I have now of my game is a better view, not that front view. There you can see the camera preview in the corner there. One cool thing is I can say, take that main camera, go into the assets, I think it's game object menu, and align it with my view. So that means just like move him to like the view I have. Now if I press play, I'll get a view that looks pretty similar to what I'm looking at, right? Cool, I'm happy with that. Our dino's like floating, so is our box floating.
Isometric view.
You can click this button and get an isometric view. There, below the little gadget, it says perspective.
Yes.
If we click that, we get an isometric view. Back to perspective, back to isometric.
And in-game isometric as well.
You would have to change your renderer.
Yes.
Yeah, your camera renderer. You can absolutely do isometric. Yeah.
Isometric will be work well for this.
Maybe. Yeah, we can mess with it. Okay, so let's add, so we got, these things, I like them in order. Let's go back to our dino, and we're going to add a rigid body, as we said, so he takes part in physics. Awesome, like that's it. Press play. What do we expect? Dino falls to the bottom to somewhere. I don't know. He disappeared.
The origin of gravity.
Yeah, somewhere.
Yes, they can solve the puzzle question.
Somewhere, yeah. Eventually things do hit the bottom. In Unity there is a bottom, but you can't get there. Okay, so let's make a world quickly. So maybe it's a 3D object and maybe it's a plane, right? So we're going to make a plane. Look at that. Perfect. Yes, I'm good, eh? It's probably not a good size, so we want to like scale it. I'm using hotkeys to get to these little gadgets, but we just say like, yeah, that looks like a good sort of thing. Cool. Now let's press play. Like better. Probably if we look at the back, we see, oh yeah, look, he doesn't fall in the middle. So we probably want to put looks like his Z in the center. Oh, not that Z. X, sorry. X centered. There we go. That Z, actually, we don't really care. Let's go back to our main camera. Oh, sorry. Oh yeah, what I wanted to do was move that out a bit. Now let's press play. Now he falls and he goes, oh, okay. Okay, almost. Like, cool. We get in there, the cool thing is the plane obviously has the ability to take part in physics as well. So Y, if we click on it, it should have a thing called a collider, yeah. So most meshes, when you create them, so if we look at our tree, for example, when I created that cube, it created the mesh. So the mesh renderer is like the cube, right? Is the object in the thing there. Unity also adds a thing called a box collider to a cube, which is to say, oh yeah, if you want, like if you want to take part in physics with this box, I'll put another box around it which will deal with collision calculations. And in fact, if I go and look at this tree, let's just open him up. There he is, and I can turn off the renderer. So now we've got no box being rendered. You can still kind of see the collision cube in there, right? So that's the thing that will take part in collision. I probably want him back. Probably the same with the plane. If we go look at the plane, we can see there's a renderer. If I turn that renderer off, I can still see that there's a mesh collider underneath. And it's no longer a box collider, it's a mesh collider because it's got like a bit more of a complicated, structure or whatever, yeah. Does that make sense? And so Unity's built-in thing, rigid bodies, colliders collide with each other, rigid bodies take part in physics, and they can bonk into colliders. And the physics engine will say, collision, so like stop falling, and then obviously like gravity pulls the okie over. Like that's totally cool, but our dino probably shouldn't fall over. So what we can do is we can add constraints to the rigid body, and we can say, we want to freeze his stuff. So we want him to be frozen in the Z and X. Z and X. We don't want him to rotate at all, in fact, right? So he must never be able to fall forward or to the side or to rotate this way. So that frees all those rotations. Let's actually just try that. It actually might just be enough. And then he'll kind of stand. So the physics engine is not allowing him to tip forward. However, he is allowed to change positions, and this could actually be cool. So let's leave that on. Awesome. So we want him to be able to jump next, I think, yes? Okay, so now we've got to write code, guys. So we're going to add a component to the dino. Oh yeah, the one thing we didn't do is this dino, probably, those mesh renderers and the rigid body only belong to the instance, right? We haven't applied those changes back to the prefab, so we probably should apply. Weird thing to do, but if you don't do it, you will get fucked later. So we're going to add a script to this dino. What are we going to call the script? We're going to call it dino. Oh, it said they already existed. Dino script. You must always name your stuff beautifully. Okay, and there it is. It's a new component, and if we double-click on this thing, your favorite tool, everybody's favorite tool, will open. Visual Studio. Why has it asked me this? Maybe it's still coming. There we go. So then we get Visual Studio opened. We can close this. That's the model solution. And we get a thing called a Dino Script opened. Do we have IntelliSense? This is the first test. Yes, we have IntelliSense. Then we have one. And you can use other stuff. You can use Visual Studio. What is it? Code. Not so well on Mac. On Windows, beautiful. Mac, fuck up. So I'm using Community Edition. It actually comes with Unity. When you install it, it says, hey, do you want to install Community Edition? You go for it. And maybe it uses Mono, not .NET Framework. I can't remember. Some weird thing with Mac. On Windows, beautiful experience. Mac, bit of a second rate, but not too bad. Okay, so let me show you how scripting works. Very simple. I wonder if there's something basic we can do just to show that this thing works. So maybe what we want to do is, so you've got kind of two functions, start and update. This makes sense. It's like run this once when you press play, and then update is like do stuff every frame. So every time the game renders, do stuff. That's the more interesting one, is the do stuff thing. So what should we do? Should we make out like Dino rotate or something, just to see this thing working, right? So to rotate him, we can just go to, like, in fact, we can just access the transform, because we know that every single game object in the world has a transform. So you've got this thing called transform. There he is, and you can say like rotate around. That makes sense. So we rotate around a point and access with an angle. It could probably even be simpler. Euler angles, that's a bit complicated. Rotate around local. Yeah, maybe rotate Euler angles relative. Yeah, let's try that. So we'll just go rotate, and then it's saying, well, what axis do you want to rotate on? And everything's a vector. So vector 3 is like a definition of a vector in 3 things. I'm not a maths person, but I can do this stuff. So you go vector 3 dot, like which axis are we rotating? Oh no, this is saying, how do you want, what is this saying actually? So when we rotate, why would we rotate? Well, let's try it. So let's rotate across the up. I don't know. Let's see what that does. So this is saying every update rotate against an up axis, which will be the Z. Y axis. No, Y. Yeah, Y. Yeah. So let's press play, see what happens. There goes our Dino. So he's rotating. Like, check at that. So like that's the scripting. It's like, wow. Okay, simple. So let's make this oak jump. That's the next thing. So in order to jump, we need to affect the physics, which means we have to talk to that rigid body, the rigid body attached to the thingy. So how do we get to the rigid body? We can't just access it directly, because Unity kind of doesn't, the code doesn't really know what we've got to attach to our object other than the transform. So we have to go and find that rigid body thing. So if we look at the components, there's a transform, there's a rigid body, and a Dino script. So the way we get to these components and access them is we literally say get component, right? And you say, well, what kind of component are you looking for? I'm looking for a rigid body, please. And you go, okay. And we say bar rigid body equals that component. Now you might say, well, what if you don't have one of those? So then you can go, cool, write tests or something. But you could print that rigid body if you like, if you want to be doubly sure. This is my kind of, the only testing I ever do. So there it is. So it's printing, there's a rigid body, right? Some kind of object. Cool. And then to rigid bodies, we should be able to do stuff like add a force. So I want to like add an upwards force, because I want him to jump upwards, right? So I want to pretend like something's kicking him upwards, right? So adding a force, we have a vector 3 of force. That makes sense. And probably there's a same one with like a different force mode. We can do X, Y, Zs, whatever. Okay, so we want an upwards force. So we'll say vector 3 dot up. And then it's like, well, what force mode? And here's an interesting one, because there are different ways of applying force, right? So you could apply like a constant acceleration force. You could apply just this force for this frame. Or I could create an impulse, which is like, I want this force like a kick or a smack. This is probably an impulse force. Like a jump is more like an impulse. I'm only going to do it for a short time, yeah. So this is a bit weird, because on update, this is going to happen every frame. So this is probably going to be a disaster, but let's see. We can press play on that, and hopefully our dinosaur disappears. Goodbye. So we applied a good impulse upwards continuously. So we probably only want to do this when we press a key, right? So very simple. We're going to say input dot get key down. Yeah, so when someone presses the down, I only want a single event. What are we going to use? Let's use keycode dot spacebar, makes sense. Then we want to, I have to go function end. Yeah, there we go. So when we press spacebar, we want to apply this force. So as I switch back to Unity, it recompiles in the background. It just on the focus change is when the compile happens. Okay, so there's our guy. If I press spacebar, you can kind of see him getting some force applied to him. But only actually when we press key down. So it's like, and actually the force is, you can see him kind of moving, right? It's because we're giving him a very, very tiny force, which is this one. It's vector3.up. And if I say like, well, what is up? Vector3.up. It tells us that it's an up vector. And if I go to up vector, oh my God. This works better in Visual Studio. But look at the description. It says shorthand for writing vector3 0, 1, 0. So it's an upward force of 1, which is not very high, considering he has a mass of 1. So it's like saying, taking a 1 kilo object and applying 1 kilogram of upward impulse to it. It probably isn't. It's just gonna break inertia or whatever, right? Not a physics person. Let's kill that thing. So already here we're going, well, okay, so we could do this, right? We could say, okay, cool. We'll take the upward force and make it like 5 times bigger. So you can multiply a vector by a float, no problem. So this is going to make it now a 0, 5, 0. And probably if we play, he'll get a bit of a better force. So like, cool. Like, that's awesome. And I could keep going through this loop and say, well, he's not really jumping high enough. So maybe I want to make this dinosaur, like I want to make that force a bit of a configuration thing, right? Like that 5. So another very cool thing is I can say, actually, I can just say public float jump force or something, and I could make that 5, no problem, and I could take that jump force and apply it down here. So now you guys are starting to see this, right? You're going, oh yes, I can make variables for things and put them inside classes. This is what I do. I now pop back to the Unity and like check it out. There's my Dino script. It's like, oh look, it's exposed that property to my editor. So now I can say, oh cool, jump force 5, perfect. So let's play that and we should see the same kind of thing. Like, yeah, it's good. But if I go back to in fact, I can go and change it. I can say, well, what about 7? Come back here and I can say, oh, that's a 7. So now I can like mess with it. I can even do this cool draggy thing on it. I can go, ooh, yeah, I actually want it to be like there. And then you can jump like quite high. So now I can say, okay, cool. So now I've got a dinosaur that actually has got a configurable jump force, right? So I'm starting to build like cool components, right? You guys have got this, right? This is just the wrong way of doing it. Any public thing just gets exposed, fine. But what you should say is serialized field, and it shouldn't be public anymore. So serialized field instructs Unity that this is a field that should be exposed in the thingy. You can add other attributes, cool ones like range. You could say like the force can be from 0 to like 50 or something. And then when I come in here, it gets constrained like that or whatever. I can also do other stuff. I can't remember. There's a whole bunch of attributes here. I think I can do grouping or header or something. Oh, header. I could say, oh yeah, this is the force stuff goes under here. Save that, and then I can kind of customize this thingy. The force stuff goes under here. I can also add a tooltip. I mean, you got it, right? So effectively, what Unity is doing is it's saying there's 2 kinds of people in the world. There are developers who write. Let's call them programmers. There are games programmers. They're the dudes that are writing these low-level components, right? But they must expose up all the properties to the other kind of person, who is the game designer. Now, the game designer is very scared of code. He doesn't know about Visual Studio, but he can design a whole game through dragging and dropping these funny things on and going, oh yes, I want to be able to manipulate the jump force of this dinosaur. So, and actually, it's a very good split. So you kind of separate your brain into 2 things. There's a games programmer piece, who's the developer dude, and then the game designer guy who tweaks the things and he builds the scenes and he makes the things and whatever. Does that kind of make sense? So there's 2 roles. And Unity separates them beautifully through this inspector thingy. You can create as many of these things as you like, expose all these properties to the game designer. But if there's just you sitting in front of it, you have to like change hats. and you have to think about yourself as a game designer and as a games programmer, but never at the same time. Okay, cool. So we've got our dino. We're happy. And he can jump, and we can configure his jump. Brilliant. It's like we're there. What else do we need to do? Do we need to go look at the thing? What else were we going to do? Make him jump. Probably need a plane. Oh, we've got to generate and move some trees. Can you see it? Are you seeing it yet? Or do you still need my help? Need help. Okay. What we're going to do is we're going to create an object called the tree generator, right?
The conveyor belt.
Conveyor belt. Perfect. I'm calling it a tree generator. Tree generator is probably a prefab. I'm going to pop him in there. We're going to go into the tree generator. Does he have any look and feel to him, the tree generator? Does he have anything on him? No. No, the tree generator, right? So the tree generator is a thing that will generate trees, right? Trees probably know how to move. Generator's just going to like make them, right? Trees will move themselves. Dino will jump over those trees. Like we'll get there. So tree generators probably don't look like anything, but what I quite like doing sometimes is put something in there so that you can kind of see where he is. So let's make it and we'll remove this later. So just for a bit of debug, let's put a sphere in there. So like the sphere is where the tree generator is. Okay, so this is what I'm thinking of doing. So here's the tree generator. We'll put him like at the end of the runway. There he is. He's probably in a weird position, but it's okay. Maybe because our plane's in a weird position. Actually, our dino's in a weird position. Anyway, whatever. We'll put a tree generator. Then probably that tree generator needs a script. Oh, not the Dino script. Whoops. Remove that. A new script called generate trees or something. These scripts have gone into a funny zone again. So OCD, you should make a directory, call it scripts. Look at this. You could like make shit neat for days here. Put it in scripts. Go in there. Generate trees. Okay. So generate trees must just do stuff, never on start, but probably on update. So it's like every few somethings we want to create a tree. Okay, so I'll generate trees. Let's think about it. Yeah. So the way we're going to create a tree is probably like this. We're going to use a function called instantiate. Yeah. And now instantiate takes an object original. So it clones the original, returns a clone. Okay, so it's like, well, okay, so we need to know the thing that we're going to create. So probably we need to know, like instantiate needs a property to say, well, what am I generating, right? So we'll use that cool serialized field thing again. We're going to say, actually, there's a game object, and we're going to call it like the tree, right? That's it. Fine. Now if we go back to Unity, go back to our tree generator, it's like the tree. And at the moment it's none, which is the same as null. So we're going to say, actually what we want is like we want the tree, right? So that he gets a reference to tree. We drag that on, and now tree will suddenly be an object which is no longer null. And we'll now be able to say instantiate the tree, right? Instantiate, we probably want to give it a position. I don't know where it will create it actually. Yeah, there. So the second one has got a transform parent. So it's like, well, what do you want the parent to be? And the parent is probably me, right? It's like my guy. I'm the parent of this tree. This is super dangerous because it's going to happen every frame. We're going to instantiate 1 million trees. Probably a bad idea. Let's just make this on start so we can see it happen once, right? Instantiate a tree. Let's press play. Vonk, like a tree appeared over the cube. Perfect. It works. Also, if I go back in there, have a look at my hierarchy. We will see somewhere here, because tree generator was the parent, he's got a child now, a new one called tree clone, which is like, who is he? If we go to the scene, it's like, oh, it's that guy. And we can move him, and we move him, and we can say, oh, the sphere is still there. But and that's exactly what we said. We said instantiate tree, and I am your parent. So that's why this thing is underneath me. If I didn't say I'm your parent, he would just belong to the scene. He would have become like a high-level thing. But that's just to be tidy. So that's cool, but trees are a bit useless. We should probably have made these trees move, first of all, right? So trees should probably every frame start moving in a direction, right? So probably trees need a script. I'm going to show you a different way to create scripts. Tree script, like that. And then I can double click it. And I can say, cool, on update. And I'm just going to fly now because like I can see it already. Serialize field float speed. So how fast should it move, right? And now we're going to say transform dot position. How did we do this? Equals transform dot position plus we need a direction. Do we? Yeah. So let's make that a thing. Serialized field, which is a vector 3 of direction. We're going to add the direction multiplied by speed. Does that kind of make sense? Any clever people can check this, because the brilliant thing about this is like even dumb people can do this. Like, look, we did it. I think we've done it. We probably haven't done it. This prefab, we've never attached the script, so we need to attach it there. There he is. Now he's got a speed and a direction. That was crap because like now it's all naught. It's nice to give these things default. So you say the speed is maybe 5 and the direction equals vector 3 dot forward. So we'll say it moves forward generally. And now when we go back, it's like it doesn't really fix it because it was already attached. So now we can remove it, add it again. Where's the tree script? Bonk. And you'll get a better default. Cool. So now if we press play, let's see if our trees move. Woo! Okay, it went, but it kind of went the right way, actually, forward, right? A bit too fast, so fine. There's one other issue here, though, is like, if I, remember this is being called on every frame, so on update, right? And if I look over somewhere, if I go to game and I go stats, it will show me my frames per second. So if I press play, even on my crappy Mac, it's, okay, that's pretty bad, actually. It's going at 80 frames per second, and that's fine, but unlike Daryl's machine or even Tanash's machine, it'll probably go at 1,000 frames a second, and we're going to have trees moving at different speeds, right? So we need to have frame rate, because at the moment we're just saying, yeah, move 5. We want to be frame rate independent, right? So a way to do that is just take your thing and multiply it by time.delta time, which says, this just gives you a floating point, which is like how long the last frame took to render. So it'll be like a small floating point number. And now when we press play, our trees will move at a more constant speed, and they're frame rate independent. But now they're going much slower, and actually it's a bit more reasonable, probably. But just a little tip, you'll experience this. Yeah, I'm not explaining to you why. Okay, so time.delta time. So we've got trees moving, brilliant. That means our generate tree thing is also generating trees, which hopefully just moved. Did they move? Let's confirm. Yes, good. They all moved, brilliant. Perfect. Probably this thing should be in update. Like we want to generate more than one tree over time, right? So the way we're going to do this is like, this is just the way to do it. I'm not sure how to explain it. We're going to create a thing called a coroutine, which is something that's going to run as like a separate, almost like a separate thread or whatever. It's going to generate trees every now and then, right? It's an IEnumerator. You know these IEnumerators in C#, right? IEnumerator, generate trees. Yes, happy? So IEnumerators, we all know how these work, right? So we go while true, because we want to generate trees forever. We're going to say return, is it yield return? Yield return, right? Yield return new, wait for seconds. Yeah. 3F. So this is an enumerator that's going to wait for 3 seconds. However, when he does that, before he does that, he should probably instantiate a tree. Agreed. And in start, we want to start a coroutine called generate trees. Ta-da! Oh, why? Member names cannot be the same as their enclosing types. Ugh. Well, call it something else then. A generate trees. A generate trees. Perfect. Okay, it works. There's some compile issue, there's no compile issue, cool. If we press play, let's see trees be generated every 3 seconds, hopefully. Yes, 3-second trees, and we can jump over them. Okay, you guys convinced, right? Are we winning yet? Look, it's like a game almost. Okay, awesome. Like that totally makes sense, but probably the game. So we'll tweak it later, right? Let's make a thing where if we crash into a tree, then we die. Yeah, it's probably a dino thing. Here's something cool. What about if a block hits our dinosaur, he explodes? Yes. So we're going to create an effect called a particle system. We're going to call that particle system an explosion. How long is it going to? Now, particle systems are very complicated, but I can do them. So it's going to run for about 0.4 seconds. I think if we click it, how do we actually make it run? I can't remember. I'm in the game view. Yeah. So as soon as you put particle systems on stuff, you get this cool little gadget appears. And you can start to go, okay, cool. So start lifetime is how long the particles live for. They probably shouldn't live for 5 seconds. You want them to live for like quite short, because that would, like explosions don't generally live for too long. However, they have a fast speed when they start, maybe like 400 or something. Their size, simulation, scaling, Rigidbody, max. Oh yeah, so emission, rate over time, this is how many, you want like lots of them over that time, you want lots. We don't want this to play on awake. And what else do we want to do? Why is it always going in a direction? Actually, I want it to be shaped not a cone, but to be a sphere. Yeah. Wow, I've never done that one. That looks cool. Hemisphere, maybe. I don't know. A sphere, right? Does that mean they're shooting outwards? Yes, I think so. Okay, so we're happy with that. We probably want some kind of color. Now, color, I always struggle to find. There it is, star color. So if we go there, we actually, like, we could specify a single color, but another cool one is like a random between two colors, right? So we could say, where is he now? So if you click there, you can say, explosions are generally like orangey to reddy, right? Seems good. The lifetime's probably far too high. Probably like that. Restart. I think if we, it's going to be a bit tricky to get this thing perfect, like in this mode. There was one other cool thing, is like the size, maybe. Start size. Was it that? Oh, I can't remember. I made a really cool one in my example. Anyway, that's fine. I'm fine with this. Explosion. So there he is, explosion. He's got play on awake off, so that means when the game begins, the particle system shouldn't run. Fine, we agree with that. If we had play on awake on, as he runs, we'd see the particle system run now forever, which is weird. That must mean that looping is on. There it is, looping. Off, play on awake off, fine. It's not the best explosion. I know that, guys. I don't know how to make it better. Scaling. I made a cool one earlier. It was one of these things, made it awesome. Anyway, that's fine. So probably we want to run this thing when we have a collision, right, with a tree. So how do we do collisions? Very simple. We go to our Dino thing. In fact, this one, you just do this. You go to this thing and you say Unity collision, and then you click on this thing, collision API, and then it says the magical function is on collision enter. Yes. Look, it even shows you like, oh yes, here it is. You take this code. And then you go here and you say it's for our Dino. Where is he? Dino Script. So is it when a Dino collides? Yes, that makes sense. On collision enter. We don't care about any of these things. So on collision enter, when we get another thing, we want to play our own particle system. So how do we get to our particle system? Get component, particle system. However, interestingly, so here's a weird one. Our Dino doesn't have a particle system on him, right? He has a something as a child, which is a particle system. So, whereas when we were looking for the rigid body, he was attached to our Dino, so we could just go get component rigid body. Here he's not attached directly to us, he's attached to one of our children, right? So we want to say get component in children particle system. And go var explosion. So this is only just one way to get stuff. You can also get stuff by name. That's also totally fine. You can go find, in fact. Find. Oh, it's transform.find, sorry. Transform.find. And I could have actually written here like explosion, spelled correctly. And that would have gone and found an object which has got that name, explosion. But that's like probably a bit weirder. And if you renamed it, it would break, obviously. And then actually on explosion, we want to just go explosion.play. So like play the particle system. Hopefully this will work. If it doesn't, I don't know why.
It's going to hit the plane.
Oh yeah, you hit the plane. Oh, why? Boxes have colliders? No. Oh, I know why. It's because our Dino actually has no box collider on him. So we don't expect him to collide with anything, right? There is a way to fix this, but I don't know. But let's just fix it by slapping a box collider on. So we'll say, yeah, the box collider is like, ooh, sorry, not him, you. I've actually got to scale him here. Best thing, yeah, I'll just leave it there, actually. We'll leave the box collider here. Size Y, maybe a bit higher, right? 3 or something. Looks good, right? And now hopefully our collision. But yes, someone is correct that, is it not working? No, it's not working. It's fucked. I do know why. I think because this is a trigger. It's a trigger collider. I think without is trigger, it was already playing. It's not playing. Damn it. Tree, where are you? Tree has no box collider. Cube. Oh, he does. Is he a trigger? I don't know. Could be. No. Doesn't work.
Is the tree actually hitting the dino?
Yeah, it's touching.
Oh, it's a good question.
Looks like it.
No, but we hit that. It doesn't. Woo! Oh, no, but that far one surely does.
The next one does.
Let's do that. Nah, it's buggered. It's buggered.
Jumping and see if it triggers again.
It will trigger because I hit the plane. Oh, I see what you're saying. Yeah, good question. So let's see if it triggers here. It does. Yeah, so when he impacts the plane.
So it's just it's not interacting with the box.
Yeah. Yeah, there's some difficulty here. There's some issue.
I think the on-touch start doesn't re-trigger if it's already touching.
I don't know. It doesn't matter that much. You will figure it out. There's a whole bunch of rules here. So if you go Unity, collisions with kinematics, there's a whole bunch of rules of how this stuff works. Because there's different kind of colliders. Some of them deal with physics, but you can see there's no physics happening. The plane has got physics again. Oh, that's actually my problem, is that my dinosaur is taking part in physics type of collisions, which is kinematic, yes. There. Yeah, is something like that.
Add a rigid body to your trees.
Could be. Anyway, something like that. Are we out of time? Is there another meeting? Yes. The end.